hopefully you've had a go at the questions on scale drawing practice. We're going to go through the answers so that you can check how you're getting on. Firstly, we need to draw our parallelogram. So to do so, we line our ruler up with one side and then we move it along, keeping it parallel until it joins the other arrow and we go across. We then repeat for the other side. Once we've done that, we draw our resultant force from the original point to the opposite corner. Remembering the arrowhead to show the direction. Now we know that the scale is 1 square equals 1 Newton, and we can check against here that each square is 1 centimetre. So we know our scale is 1 centimetre represents 1 Newton. So to find out the size of our resultant force, we can measure accurately the length, which to me looks around about 6.7 centimetres. Because we've got a nice simple scale, we know that to go from 1 to 6.7, we multiply by 6.7, so we want to do the same to this side, which gives us 6.7 newtons. All of these answers will have a range. They're not expecting you to get it perfectly spot on, so as long as your answer is somewhere in the vicinity of 6.7 newtons, you'll probably pick up the marks. Okay, we'll do the same thing again for the second example. So again, we're lining our ruler up and we're moving it parallel, and we're doing the same to the opposite side. Once we've constructed our parallelogram, we then want to draw our resultant force from the origin to the opposite corner, like so. Again, we've got our same scale of 1 centimetre to 1 Newton, so we're going to measure the length, which looks to be approximately 7.8 centimetres. And again, because of our simple scale, we're multiplying both sides by 7.8, which gives us 7.8 newtons. In these second examples, don't be put off by the fact that we're not using rectangles. It's exactly the same process to make our parallelogram. So again, we draw our line by making sure our ruler is parallel, we move it up to the opposite side and we draw across. And again, it's better to go further than you think you might need. And we do the same with the opposite side. So we take our ruler, we put it on the side, we keep it parallel and we slide across. Now we've constructed our parallelogram, again we need to add on our resultant force, going from the original corner to the opposite corner, like so. Again, we're using the same scale. 1 centimetre represents 1 Newton, so we need to find the length of this arrow in centimetres, which, looking at mine, looks approximately 9.6 centimetres, which will equal 9.6 newtons. Okay, I'm going to go through the rest of them and you can check your answers off at the same time. hopefully you're a bit more confident at drawing scale diagrams to work out the size of resultant forces.